Obtain moment generating function, mean, variance and covariance for the multinomial distribution. The solution: moment generating function is given by mxt, mx1, x2, xk, so on xk, bracket starts t1, t2 and so on tk, bracket close, which is equal to e square bracket starts exponential curly bracket starts sigma I varying from 1 to k ti xi curly bracket close square bracket close, which is equal to sigma x square bracket starts n factorial upon x1 x2 factorial so on xk factorial, p1 raised to power x1, p2 raised to power x2, pk raised to power xk exponential bracket starts sigma I varying from 1 to k ti xi bracket close square bracket close, which is equal to sigma x square bracket starts n factorial upon x1 factorial x2 factorial so on xk factorial, bracket starts p1 e raised to power t1 bracket close whole raised to power x1 bracket starts p2 e raised to power 2 bracket close whole raised to power x2 plus so into so on, bracket starts pk e raised to power tk bracket close whole raised to power xk square bracket close, is equal to bracket starts p1 e raised to power t1 plus p2 e raised to power t2 plus so on plus pk e raised to power tk bracket close whole raised to power n, where x is equal to bracket starts x1 comma x2 comma so on xk bracket close. Now m of x1 t is equal to mx bracket starts t1 comma 0 0 so on 0 bracket close is equals to bracket starts p1 e raised to power t1 plus p2 plus p3 plus so on pk bracket close raised to power n is equal to square bracket starts bracket starts 1 minus p1 bracket close plus p1 e raised to power t1 square bracket close raised to power n, which implies x1 is congruence to b bracket starts n comma p1 bracket close by the uniqueness theorem moment generating function. Similarly, we get x1 is congruent to b bracket starts n comma pi bracket close, where I is equal to 1 to so on k mean and variance exi is equal to square bracket starts del upon del ti square bracket close t is equal to 0 is equals to square bracket starts del m upon del ti bracket close t1 is equal to t2 and so on tk is equal to 0, here t is equal to t1 t is equal to bracket starts t1 comma t2 comma so on tk bracket close is equal to square bracket starts npi e raised to power ti bracket starts p1 e t raised to power ti plus p2 e raised to power t2 plus so on pk e raised to power tk bracket close whole raised to power n minus 1 square bracket close, t is equal to 0 equals to npi e bracket starts xi square is equal to bracket starts del square upon del ti square bracket close t is equal to 0 equals to npi square bracket starts eti e raised to power ti brackets starts p1 e raised to power t1 plus so on pk e raised to power tk bracket close raised to power whole raised to power n minus 1 plus eti e raised to power ti bracket starts n minus 1 bracket close pi e raised to power ti bracket starts p1 e raised to power t1 plus so on plus pk e raised to power tk bracket close raised to whole raised to power n minus 2 square bracket close t is equal to 0 is equal to npi square bracket starts 1 plus bracket starts n minus 1 bracket close pi square bracket close e xi xj is equal to square bracket start del square m upon del ti tj square bracket close t is equal to 0 where ti does not I not equal to j is equal to square bracket starts n pi e raised to power ti bracket starts n minus 1 bracket close bracket starts p1 e raised to power t1 plus so on plus pk e raised to power tk bracket close whole raised to power n minus 2 pj e raised to power tj bracket close t is equal to 0 n into n minus 1 pi pj since p1 plus p2 plus so on pk is equal to 1 variance xi is equal to e xi square minus e xi bracket close square bracket close whole raised to power 2 ni pi square bracket starts 1 plus small bracket starts n minus 1 bracket close pi square bracket close n minus n square pi square is equal to n pi plus n square pi square minus n pi square minus n square pi square is equal to n pi minus n pi square n pi bracket starts 1 minus pi that is equals to n pi qi. Now covariance is equal to covariance xi xj e xi xj minus e xi e xj is equals to n into bracket starts n minus 1 bracket close pi pj minus n square pi pj equals to n square pi pj minus n pi pj minus n square pi pj is equal to minus n pi pj.